Okay, welcome back. I want to just mention a couple of things about measuring things in fractions and in thousandths of inches and some basic ultrasonic terminology to get ourselves started. So I'm going to start here by saying that if we had something that was a half inch thick or a half inch in diameter, in terms of thousandths of an inch, we would say that would be 500 thousandths. Or if something was a quarter of an inch, we would say that would be 250 thousandths. Or an eighth of an inch would be half of 250, 125 thousandths. Or a 16th of an inch. In exact terms, that would be 0.625. That's actually in 10 thousandths of an inch. And we're going to adapt the convention, stay with the convention that we just express everything in terms of thousandths of an inch. And so if we were to round that off to 3 digits, by rights we should round that up to 0.63, but I'm going to leave it as 0.62 because I think that's the way I see most people referring to that. And then 1/32 of an inch, in terms of thousandths of an inch, would be 0.3125. And that would be 3125 hundred thousandths of an inch, I think. But we're only going to use 3 decimal places, so we're going to get rid of that. We're just going to call it 0.31. And that would be expressing the things in terms of thousandths of an inch, or fractions of an inch. The other term that we often use is actually mils, and that would be just calling out 500. Like 1,000th of an inch would be 1 mil. So in terms of mils, quarter inch would be 250. 1/32 of an inch would be 31. I just like to mention that because I throw out terms about fractions and thousandths of an inch, and I use them interchangeably sometimes. It's a good idea to get exposed to that. Another thing that we'll run into a lot is a 1/10 of an inch. And in terms of 100 thousandths, thousandths of an inch, it would be 100 thousandths. And 2/10 of an inch would be 200 mils, and so on. A 300 whole would be 3/10 G. All right, and then I just want to mention some terms, some angle beam testing terms, so we don't have to do this later. Stay put. There we go. You gonna stay? So if we had a material, and that was the top outside surface, and that was the bottom inside surface, like that was the thickness of the material, we refer to this as the OD, and this as the ID, outside diameter, inside diameter. This is usually the surface that we would have access to for testing. And if we put an angle beam search unit on it, say for example that was the wedge for a 45 degree, and we had our transducer screwed into the wedge. I'm going to draw this as if the sound comes out of there as a laser beam, but really it's more like a shotgun blast of sound. And there's going to be some refraction, because the sound is going to go from the slow velocity in the plastic to the higher velocity in the steel. So there's going to be a change of angle there. And that 45 degree sound will come out, and it'll echo and bounce and just keep bouncing like that. We refer to this as leg 1, and this is leg 2. This would be leg 3. And when we measure these angles, we measure them from the vertical. So that's our 45 degrees right there. Now, in the case of a 45, if this is 90 degrees and this is 45, then this would be 45 also. And I mention this because I always wanted the angle, when we mention an angle, to be this angle, but it's this one here. We measure it from the vertical. which it doesn't make any difference for a 45 because it's 45 either way. But if we're measuring a 60 degree, that would be 60. And if we're measuring a 70 degree, we measure it from the vertical. That would be the 70 degree there. Let's see, what else have we got here for terminology? This leg 1 plus leg 2, that's the V path. That would be a full V in the shape of a V. Leg 1 by itself is a half V. All three legs, that would be a V and a half. Another term we'll see is skip distances. A skip distance is a surface distance, and that's where the sound enters the material to the end of a full V. That would be a full skip distance from here to here. Some people use those terms interchangeably, a full V and a skip distance, but really a full V is a volumetric visualization, and a skip distance is a surface distance. Another thing we'll run into is, okay, say you had a reflector out here. You know, we could, knowing the velocity of the sound, we can measure how much time it takes for the sound to go out to the reflector and come back. And knowing that, we could use trigonometry to calculate the depth. By the same token, we can use trigonometry to figure out what that surface distance is. This being the surface distance above the flaw from here to here. Another term we'll run into is the distance from the index point, where the sound enters the material, to the front of the wedge. That's given this arbitrary term of X value. And we like using that term because if we had a reflector, we often want to know where that is below the surface. And if we try to measure from that index point, it can be kind of difficult. It's going to look easy here on the chalkboard, but sometimes it can be difficult to see that, where that index point is. This is what an actual 45-degree search unit looks like. It can be pretty hard to find that little point right there. It's a lot easier to take an actual measurement from the front of the wedge, because you can just put it right to the front of the wedge and then get your measurement. So this measurement here is called surface distance minus X value. Surface minus X value. And we use that a lot. I think that gets us enough of a starting point to continue on. So thanks a lot, and we'll see you on the next video.